Okay, hello. How are you? Good. Online student. Seeing okay?
Good.
Listening okay?
Yep, I can hear you.
Yep, all good.
Good, okay. Last class, we stopped there. Weighted moving average. And today, from this one, start from this one. Exponential smoothing. Last time when we cover weighted moving average, the idea was most recent data is more important and so on. So give more a higher weight. Same idea. Instead giving a weight using this formula, give it weight. Alpha is smoothing constant alpha, depending on how much it affects. So usually this alpha is given. So using this formula, we can get weight, most recent weight, alpha times 1 minus alpha, given alpha, 0 power, and 1 power, power 2, 3, and so on. Then weight is 0.05, 0.04, 0.0451 decrease, like this. So using this alpha and exponential formula, we can get the most recent forecast, actual forecast, and alpha. And using this formula, we can get forecast. Some t, if we want to forecast some t, ft equals ft minus 1. ft minus 1 is one term earlier, most recent, plus alpha, smoothing constant, times at minus 1. A is actual some t demand minus forecasting ft minus 1, that is forecasting one term earlier. So example, the last month's forecast, 22,000 loaves. This is ft minus 1 in formula ft minus 1, and 21,000 loaves were actually demanded. So 21,000 is actual demand one time earlier last month. So at minus 1, and alpha is given 0.01, and just plug in. ft minus 1 is 22,000 plus, given alpha is 0.01, and then at minus 1 is 21,000 minus ft minus 1, 22,000 equals 22,000 minus 10 equals 21,990 loaves. So using this formula, we can get forecast demand for term T, exponential smoothing. But if we use this exponential smoothing, then one thing, problem. Lagging behind. The exponential forecast always lags behind the actual occurrence. Like this, actual, this black line, actual demand. And then if we use alpha equals 0.5, alpha is 0.3, 0.1, then if actual demand top, the peak is here, here, then if we use 0.5 alpha, the peak is here. And then 0.3, lagging behind more, 0.1, lagging behind more. So to correct this error or problem, we use one more smoothing constant, delta. Smoothing constant delta reduce the impact of the error that occurs between the actual and the forecast, lagging behind the problem or error. We call this technique as exponential smoothing with trend. So formula more complicated, looks like FIT, that is forecasting including trend, FIT. Term T FIT equals term T forecast. That term T forecast comes from this formula. Looks like exponential smoothing, but difference is in FIT, using FIT. And then plus T. T, this one comes from this formula. Trend T, T is trend. Term T trend equals one term earlier, T minus 1, trend plus delta, smoothing constant, times FT. This one comes from this calculation, plug in, and then minus FIT, T minus 1. Example, if F11 equals 100, T11 equals 5, alpha equals 0.1, delta equals 0.3, and actual demand equals 110. Then what is FIT, forecasting, including trend, term 12. So given term 11, here, term 11, 11, 11, forecast, term 11 trend, term 11 actual demand, then what is FIT 12. So go back to, and I will write plus T FIT A. Online, can you see the chalkboard?
Yeah, we can see it.
Okay, good. Bigger or, yeah, bigger. Okay, now from given numbers, F11 not here, A11 is given, alpha is given, delta is given. To calculate F12, we need FIT11, but FIT11 is not given. It doesn't give you a FIT11. What do you think? Can we solve this problem without FIT11? No answer. What do you think in class? No idea? Okay, I will. Here, FIT12 equals F12 plus T12. As long as we know F12 and T12, then we can get FIT12. From that idea, if we know F11, T11, then we can get FIT11. F11 and T11, they are given. So we can get FIT11 from this little calculation, then plug in FIT11 and so on. Understood? Okay, change. So we know F11 100, T11 5, so we can get FIT 11 with this calculation. So FIT 11 equals 100 F11 plus 5 T11. So FIT 11 is 105. Then plug in FIT 11, F12 equals FIT 11 plus alpha A11 FIT 11. So FIT 11 is 105 plus 0.1 alpha 110 A11 minus 105. So F12 is 105.5. T12 equals T11 given 5 plus delta 0.3 times F12 from calculation 105. Calculation here 105.5 minus FIT 11 105 equals 5.15. So FIT 12 equals F12 105.5 plus T12 5.15 equals 110.65. Question? Okay. Screen. Where is this one? Mhm. You have a practice problem on Moodle. What's that? This practice problem, question C. Question C is similar one. What's that? Somebody close my screen. Okay. This problem, question C is similar one. So if it is in a regular class, then I give you time to practice, and then I check if we do well or not. But because this one is hybrid class now. So I will let you do this sometimes when you are available. By the way, on Moodle, I posted an answer, so you can compare with your answer to my answer. And also, tonight, I will record how to solve this problem, and then post on Moodle. So if you need, then watch my recorded video about this one. And you have, why it doesn't work? Today's network is slow. You have assignment. This assignment is similar to that question using FIT, exponential smoothing with the trend. So open this assignment. Then there is a file, assignment 1. So download this file, complete and upload. You may upload whatever form. You can just answer on the paper, writing, and take picture or scan, or using the Microsoft Word. Then save a file and then upload whatever. So try. Due is next Tuesday, midnight next Tuesday. That is 8th of September. When you take the midterm, I don't remember exact day, but the questions for midterm will be 4 questions. One of them is similar to this one. So practice problem, do practice problem, and then do this assignment. You know, this is an online and hybrid. And then even in-class students treat like online, the same. The assignment is online. Yeah, even it is now face-to-face, the same situation. Please don't copy others. Try yourself. If you cannot do, then email me, contact me, ask me. If you need one-to-one with me using a Zoom meeting, I will give you like a tutor. So try yourself, okay? Try yourself first, and then still you don't know. Maybe you can ask your friend, but don't copy. If you copy others, later when you take a midterm, you need to study more. When you take a midterm, I try to prevent copy and paste. And then I try to make something. So try yourself. And then make yourself, you can do it, okay? And more. So that is exponential smoothing with trend, FIT. And next one, causal relationship, linear regression analysis. Many operations management instructors skip this part, but I just cover, but not in test, not in assignment. So just show you what it is. So feel free, just listen. Linear regression analysis, regression, a functional relationship between two or more correlated variables. I'm not sure. You took statistics. I'm not sure. Your statistics instructor covered this part or not. Anyway, I think you know about the correlationship. Two variables, x and y. Find the relationship, using that relationship, do something. For example, temperature and ice cream demand. Probably temperature increase and ice cream demand increase, decrease and decrease. Ice cream demand and temperature has a relationship, correlated. So find that relationship. And using that relationship, develop function, regression function. When we find regression function, we use least square method. If actual demand, black dots are actual demand, then find this regression function using this least square method. So we can find any line, but among them, the distance between actual and forecasting regression line square. So this one is actual minus forecasting line or regression line square, and next distance square, and so on. And then using derivative and equals 0, then find this formula. The function y equals a plus bx, then a equals y bar, average of y variable, minus b, slope here. So calculate slope first, and then b times x bar, x variables, average, mean. And then B equals sum of xy, x times y, x variable times y variable, minus n, that is sample size, then x bar times y bar, divided by sum of x square, x variables square, and sum minus sample size, x variable, mean of x variable square. So if we have data like this, x variable is 1, 2, 3, 4, looks like time series data. And then y, demand is 600, 1,550, and so on. Then to use this formula, then we need some calculation. We need xy, so x times y, and sum of, and then we need x squared, and then sum of, and then x bar equals 6.5. X bar is sum of x divided by 12. Sample size is 12, so 6.5. X bar square, x bar 6.5 squared equals 42.25. Y bar, sum of y divided by 12, so sample size n. So y bar, mean of y variable equals 2,779.17. So plug in. So B equals sum of xy minus sample size x bar times y bar, sum of x squared minus n sample size times average mean of x variable square. So plug in like this. So B equals slope. B equals 359.61, and then A equals like this, and so on. So we can get regression function or forecasting function like this. So y equals 441.7 A intercept plus slope 359.61 x. So using this formula, we can forecast. So using forecast, we can get like this. So if x variable is 12, plug in 12 and 4,757.1 here. And then forecast demand for March next year. Because x variable is time series variable data. So next year's x variable is like this. This year's January 1, February 2, December 12. Next year, January, x variable is 13, 14, 15. March, x variable is 15. So plug in 15, and then forecasting demand for March next year is 5,835.85. I don't know if you have a chance to take advanced course like management science or we don't have, but management science or analytic course, then using a computer. Then this regression analysis using computer is simple and easy. But I just show you how it works. So it works like this. But this one is not in a test, not in a assignment. Just let you know. Regression analysis is like this. Any question? Okay, next Monday, Labor Day, no class. Until next Wednesday, I will keep this formation. Monday class, Wednesday class, separate, and then simultaneously online, hybrid, but don't know yet, depending on how many students. Today, only 4 students in class, face-to-face. So we have only 12 seats, but maybe we can get a bigger classroom, then make one day, like a Monday in class, hybrid, in class, combine in class face-to-face and online. Then maybe we can make Wednesday class totally online like that. I don't know if it is an exact number or not. Very good. 2 cases, 2 students infected so far. Maybe more, but who knows? So as long as the case number increase, that means higher chance, right? So if that, according to that information, then decide if we go that way or that way. So let's see, okay? Okay, say again, you have an assignment on Moodle. So find that assignment file on Moodle and then do it. Before that, if you need a practice problem, doing a practice problem, try. And then, by the way, I will record the practice problem, how to solve that practice problem, and then post that recorded kind of lecture on Moodle tonight. Any question? Okay, if you don't have question, then it's early, but that's all. And see you next Wednesday. Okay. Thank you.
Have a nice day.
Thank you too.
Thank you. Have a nice day.
Thank you too.
Have a good weekend, Professor Ken.
Thank you too. Okay, thank you.